Hello everyone, this is the demonstration video for task 3.3D Buddy System. My name is Om Tomar and my teammate is Aditya. So the agenda of today's video is explaining Buddy System. So what is Buddy System really? Creating a communication system that facilitates seamless interaction between two Arduino devices through the utilization of publish and subscribe technique. Think of it as a way to exchange virtual signals with the companion Arduino Buddy, akin to sending and receiving messages via MQTT. MQTT stands for Message Queuing Telemetry Transfer Protocol, specially designed for IoT. MQTT offers an efficient publish-subscribe messaging framework, making it an excellent choice for connecting diverse remote devices even in scenarios with limited network bandwidth.
Coming on to the objectives, we have set up an Arduino that sends wave signal to any registered Arduino device, Buddy. When motion is detected on main system, the LED will flash 3 times notifying motion detection. Now with these objectives, we face some challenges like sometimes Arduino Nano 33 IoT is unable to connect to network. So one should make sure hotspot is turned on and credentials are correct in the code. The components required for this setup are 2 Arduino Nano 33 IoTs, one ultrasonic sensor HC-SR04 and LED and jumper wires.
Now let us understand publish-subscribe model. The publisher is the client who sends the data, whereas the subscriber is the client who receives the message from the publisher, and all this functioning is driven by a third party called MQTT broker. As you can see in this image, MQTT client publish is the data to the MQTT broker and it exchange values with database, and subscribe models receive the messages from MQTT broker. Talking about MQTT, this is the website for MQTT, which is known as HiveMQ. HiveMQ is for MQTT Communication. You can refer this link to see the page for subscription, and you can create a topic like I have created SIT210/waves. So whenever I publish the messages, I can see the messages over the website itself. Now let us move to the implementation. For implementation, this is the circuit diagram for publisher model, and in this circuit diagram you can see there is an ultrasonic sensor who is connected to Arduino Nano, which is Arduino Nano 33 IoT. Now when you see the pins connected, the GND pin is connected to GND and echo pin is connected to D3, whereas trigger pin is connected to D2, and VCC is connected to VIN for 5 volt.
In this circuit diagram for subscriber, we can see that the cathode of the LED is connected to the ground pin of Arduino and the anode of the LED is connected to D2 pin of Arduino Nano with a resistor in between.
As you can see, here are the code snippets for publisher. And in the code, you can see we have first included necessary libraries like Arduino MQTT client, Wi-Fi Nina, Wi-Fi 101, ESP, and Wi-Fi. Then we have checked the port type and include the appropriate libraries based on the board. And then we are using if-elif and end-if. Now then we have defined the Wi-Fi credentials. After that, we have defined the pins for the ultrasonic, which is trigger pin 2 and echo pin 3 as we discussed in the circuit diagram. Then we have declares variables for ultrasonic sensor, which is duration and distance. Then we initialize Wi-Fi client and MQTT client. Then we define MQTT broker information, which is broker.mqtt-dashboard.com, and our port selected is 1883, and the topic we made, as you have seen in the website screenshot, we have named our topic SIT210/waves. Then there is a time interval for sending MQTT messages, which is every 1 second. After that, we have counter debugging purposes. Then after that, in the setup, we have initialized the serial communication at 9600, and it will run till serial is not false, which means it waits till serial port is connected to the board. Then we attempt to connect to the Wi-Fi, and it prints attempting to connect to Wi-Fi in the serial monitor. After it got connected, it connects to the MQTT broker, and then the infinite loop runs. And when we got connected to the MQTT broker, it escapes the if condition. In the void loop, we have call poll regularly to allow the library to send MQTT keep alives. This prevents disconnection by the broker. To avoid delays in the loop, we have used blink without delay strategy. And then we have called the detect motion function which we have declared below, which detects the motion using the ultrasonic sensor. And whenever it receives a certain distance, it sends the message Aditya wave is detected and the corresponding distance to the buddy.
Now moving on to the code for subscriber. This code is an Arduino sketch written to connect an Arduino board to an MQTT broker over Wi-Fi and subscribe to a specific MQTT topic. It also controls an LED and blinks it when a message is received on the subscribed MQTT topic. It starts with including necessary libraries which are required for the working with Wi-Fi and MQTT. Depending on the type of Arduino board, the libraries that are included are Arduino MQTT Client, Wi-Fi Nina, Wi-Fi 101, ESP8266 Wi-Fi, and Wi-Fi. The preprocessor directives, example #if defined, checks the type of Arduino board. Depending on board type, specific libraries or configurations can be included, which allows the code to be compatible with various Arduino boards. Wi-Fi network credentials that are SSID and password are declared in the code to connect to the local Wi-Fi network. The LED, which will be controlled on the basis of MQTT messages, is connected to pin 2. For Wi-Fi and MQTT client setup, two objects are created which are Wi-Fi client and MQTT client. Wi-Fi client is for establishing a Wi-Fi connection and MQTT client uses the Wi-Fi client to handle MQTT communication. Moreover, MQTT broker's address, MQTT port, and the MQTT topic to subscribe to SIT210 waves is also defined. In the setup function, the code first initializes serial communication for debugging purposes. It then configures the specified LED pin as an output to control an LED. The function proceeds to establish a connection to the designated Wi-Fi network, and it patiently waits until the connection is successfully established. Finally, it attempts to connect to the MQTT broker, and in case of a failed connection, it outputs an error message and enters an infinite loop, ensuring that the program does not proceed until a successful MQTT connection is established. A custom function named blink is defined to blink the LED 3 times with a 200 millisecond delay between each blink. At last, the loop function operates in a continuous loop, constantly checking for incoming MQTT messages from the client. When a message is detected, it first prints details about the message, including the topic and size, and then proceeds to read and display the message's content. Furthermore, upon message reception, it triggers the blink function, causing the LED to blink 3 times. This loop continues to run continuously, monitoring for new messages, ensuring a responsive interaction with the MQTT broker.
As you can see, the code is being uploaded to both the Arduino Nano number 33 boards. After the code is successfully uploaded, we open the serial monitor to monitor what's happening. It's evident that the systems are attempting to connect to the hotspot named DUA. Once they are connected to the network, they establish a connection with the MQTT server. Now, whenever motion is detected in the published system, it sends a signal to the buddy system, which turns on the LED of that system. Here is the system working.
Thank you all for watching. I hope this video was informative to you all.